Good afternoon, ladies and gentlemen. I welcome you all for today's e-conference on lab digitalization, delivering efficiency and sustainability, organized by Indian Chemical News in collaboration with Dassault Systems. Myself, Praveen Prashant, editor Indian Chemical News, will be your host and moderator for today's e-conference. Just a brief backgrounder for today's e-conference. The conventional paper-based laboratories are often error-prone, making knowledge transfer even more difficult. However, with the rise of technology and remote working, managing a digital laboratory offers many benefits. Going digital also makes it easier to access information from anywhere and organize and store information. With this brief backgrounder, let me start this e-conference on topic lab digitalization, delivering efficiency and sustainability. Next slide. The presenting partner for today's e-conference is Dassault Systems. Next slide. Let me introduce you to our speakers. The speakers for today's e-conference is Ms. Bijal Matkar, R&I Director, Solvay Research and Innovation Center, India. Just a brief about Bijal. She is a chemical engineer with 17 years of experience in process engineering and research and innovation with leading specialty chemicals MNC as well as EPC firm. Currently Site Director at Solvay's Research and Innovation Center at Vadodara. She is responsible for R&I programs in the field of specialty chemicals and material sciences, as well as general site management. She has worked with cross-functional teams in both India and USA, making an impact in idea scouting to scale up for industrial operations. She has made significant contribution in areas of new molecule design, customization of existing products and applications of bio-sustainable chemistry. Next speaker, Dr. Frank Schaffar, Industry Process Consultant, Dassault Systems. Dr. Frank Schaffar acquired his PhD from Albert Ludwig University in Freiburg, Germany in organic chemistry. He is working in chem informatics business for more than 25 years and is currently managing the technical sales organization for BioVia in Europe at Dassault Systems. He has experience in lab data management systems, electronic lab journals, formulations, and data analytics. He has gained comprehensive industry insight, working on digitalization projects with many leading companies in the chemical and consumer packaged goods companies, helping them to go from manual paper-based systems to electronic and finally full digitalized solutions. Our next speaker is Dr. Jain D. Umaria. He's the Associate Vice President, R&D, Godrej Agrovet Limited. Dr. Jain did his early education at Goa University and did his PhD from Indian Institute of Science, Bangalore, with Professor G. Mehta while working on total synthesis of natural product. He then joined Max Planck Institute, Dortmund, in Germany, as Alexander von Humboldt Fellow with Professor H. Waldman for 2 years and explored total synthesis of natural product on solid support. After his postdoctoral studies, Jain joined Syngenta Research Center in Goa in 2006 and later held group leader position there. He has published and co-authored 17 articles in internationally recognized journal and possesses 20 patents. From 2016 till today, he is heading the R&D crop protection business at Godrej Agrovet, Mumbai. Our next speaker is Mr. Ganeshan Balakrishna, GM R&D and Special Projects, Sudarshan Chemical Industries Limited. Ganesh Balakrishna is a scientist with excellent managerial skills and is an organic chemist by education with a PhD degree from ICT, Mumbai. During an industrial career spanning over 25 plus years, he has gained experience in various fields like polymer, catalysis, pigments, and waste management. He has a proven track record of successful implementation of 30 plus projects at commercial level during his association with companies like Sheikh Saria, currently Teva India, Deepak Nitrite, GE India Technology Center, Porus Laboratories, Syngene International, and Sudarshan Chemical Industries Limited. He is also co-inventor of 15 plus patents. His field of interest are conventional chemistry, process intensification, catalysis, scale-up activities, and waste management. Next slide. The key discussion points for today's panel discussion is management challenges in a conventional paper-based laboratory, exploring laboratory IT solutions for error-free outcomes, optimizing laboratory processes to enable consistent productivity, current trends and case studies on successful adoption of digital tools, reimagining digitally integrated and automated laboratory for tomorrow. Next slide. The upcoming e-conferences on May 31, we are doing on hydrogen, energizing the energy ecosystem. June 17, paints and coatings challenges and opportunities. June 22, ports enabling growth of chemical industry. So would request all our delegates to please register for the event. So with this brief presentation from my side, now I would request Dr. Frank Shafar, industry process consultant, Dassault Systems, to give his presentation. Over to Dr. Frank Shafar.
Okay. Let me share my screen. Can you actually see my screen?
Yeah, we can see your screen, sir. Please go ahead.
Very good. And thank you very much. I'm very happy to be invited to present today. I'm representing Dassault Systems, as we already heard, and I'm giving you an insight about what I've learned in my recent 10-15 years working with many chemical companies worldwide to implement digital solutions, going from kind of paper-based or semi-electronic environments to digital environments. And I want to highlight what really the key components are and what is important in this endeavor to move to a digital environment. The agenda, first I want to talk about the aspects of digitalization, what needs to be considered, what needs to be in the scope of digitalization. For me, very important, and also for my customers, is data acquisition, how to collect data. What is the meaning of fair data? We'll talk about that a little bit. And then I think what I'm seeing is really kind of a critical challenge is structures versus unstructured data. How to handle it, how to collect it, what can you do with it, what are the implications? I want to talk a little bit about successful digitalization projects. What does it need to really be successful? What needs to be taken into consideration? And I also brought some use cases from the chemical industry where we helped our customers, and then finalize with a short conclusion. In terms of aspects for the digitalization, there are many things that need to be considered. Mainly people are doing experiments. You are trying something out, mix things together to get a new product, and then determine, has the product really the new features, properties that you were looking for. For that, you need to work on instruments and collect data from instruments, might be synthesis instruments, might be analytical instruments, might be automation instruments. All of them are producing data, and it's vast amounts of data. During the last years, the amount of data that has been handled in the labs has exploded. Everything is producing information that needs to somehow be stored and somehow be analyzed. Many companies are looking towards data marts and data lakes to store information. Getting it from the experiments, from the instruments into those data lakes is an important challenge. But this is just the data aspects. When our companies that we are working with are looking at a digital implementation of their labs, it's not just around adding some software, adding some hardware components. It's always kind of a possibility to review processes that are in place. Are we still relying on processes that have been established when we were working on paper? Or does the new environment allow to optimize processes, to be faster, to be more efficient? Very important is, especially if we are working with global companies, also standardized processes, so that an experiment that is done, a measurement that is done in Pune on an instrument is the same like in Shanghai, like in Berlin, like in New York. So you need to be able on a global basis to rely on data, and this is only possible through standardization. When we are looking at large organizations, it's also important to respect security. Many of our customers are working in a business-to-business relationship where they have NDA, non-disclosure agreements with their customers. They are producing new polymers for BMW, for VW, for Mercedes, or for an aerospace company. And none of the, only the people working on the project are allowed to see the information. Co-workers that are not related to the project are not allowed to see those due to the NDA. So security is a very important aspect of this digitalization. And also, we already touched on this in the standardization, is you need to communicate. Our customers need to bring teams that are working on similar projects, working on similar research topics together in terms of the departments, but also globally in terms of the sites. So these are all the aspects that we see important when it comes to digitalization in the lab. When I'm looking at recent requests for proposal, when our customers are sending our requirements, you can always see the market trends as the top goals that the company wants to achieve. They are talking about efficiency, being more efficient, driving more experiments with the same equipment and the same people, sustainability, to reduce the carbon footprint, to reduce waste, and to be quicker in terms of innovation, get more new products out in the market in a faster time. And the goal is really to drive this through digitalization. So with R&D, generate ideas faster and process them through the life cycle much faster, so that we can get faster to the market with the new product, to be more sustainable and to avoid unnecessary work. When we are looking a bit deeper into this R&D digitalization, it's all about managing the knowledge. We also talked about the aspect of automation and other pieces, but initially everybody of our customers is looking at knowledge management. So there are these three areas. There is the data collection. So all the R&D data sources need to somehow be collected. And very important is that there is an agreed way how to capture the data. This is something that the internal departments have to find out, have to agree on, have to have a common voice to store the data in an agreed way. When we are looking at this data storage, as already mentioned, data lakes are in the moment very important to our customers, where you store the data with its metadata, so that the data can be analyzed looking at different aspects. And here important again is a common ontology, that things are named the same way, so that you can later on compare experiments. Only then you can go to the next step, which is the knowledge generation. Many of our customers are doing today already data analytics and visualization. They are looking visually at the data, creating curves, creating radar plots. What all of those RFPs that we are getting in recent times is looking at is reuse the data even more for machine learning and artificial intelligence. What does this mean, reusing the data? What we want to provide and what our company is providing is virtual twins of production of experiments. So we try to build models that are predicting experimental results. We only can do this based on existing tests, so that there is the real world where we need to capture the data from experiments. And if we have a large amount of this data, we can start to look into the data and build data models. These data models are then fed with virtual configurations, virtual experiments to find what is really the best experiment, so that a scientist is not doing 100 experiments where most of them are actually going to fail. He's going to focus on those experiments that the model has predicted to be really successful. With that, we are getting reuse of the data. We have a scientific innovation life cycle, and we are getting to more sustainable product and quicker commercialization of our products. But what is the situation at the customers today? They have numerous silos of different technologies where they store information. Some people are adopting quickly the technology, others are a bit lagging behind. Very disconnected sometimes is the IT department from the business in terms of what is needed and what can be supported. The communication, we already touched upon this, is very important, that departments are communicating with each other, have a possibility to exchange information and results. These things are all playing together. What we're hearing from the customers is also, oh, we have collected a lot of data already, but it's sitting there and we want to take value out of it. We want to build models out of it. We want to reuse it for data analytics. Or if we want to upgrade the software environment that we have already in the lab, how can I make all my historical data accessible to my people? And finally, even if you have old data, sometimes in written books and lab journals, it's sometimes too hard to find the old data, so that it's easier to redo an experiment, which is of course time consuming and not sustainable. So these are kind of statements we are getting from our customers. What really is needed, and this is what we are proposing to our customers and what they are actually asking for, is to support the innovation process on a scientific basis, really doing collection of data and building the models. And for that, it's really important to start with structured data, collect structured data. This is the basis for the whole data continuity. So the scientific data needs to be collected and stored. And then on this structured data, we can start easily to do data analytics, which today take a bit of time. And this is what companies are doing already now on a regular basis. But what we want to do is really then take the data forward and build these predictive models on materials, formulations, and predict their performance. Only then we can really empower the decision-making, guide the scientists to the right direction, what kind of experiments to do, and with that, accelerate the product research and decrease the time to market. This is the kind of data modeling engine that we try to power. What most of our customers actually are facing, and this is really a surprise, you think companies are already far ahead, but many of them are still documenting their work in paper. Many are also already steps ahead and document electronically, I would call it, taking the data into Excel sheets or into Word documents, and then they are storing them somewhere on their local drive. They send them via email, store them on SharePoint if you are lucky, or in a shared file environment. But is this really fair data? Everybody talks about fair data, and there are 4 guidelines that are making up fair data. F stands for findable. It needs to be, the data needs to have a sufficient rich metadata in order to be useful. It needs to be accessible, so that the data and the metadata are understandable to people, but also to machine reading, which is a very critical part. And then they need to be interoperable. meaning that they are can be used in a formal, accessible, and shared way. The last part of the FAIR data is really that it is reusable. The data and the collection of the data, you're not collecting this just for fun. It has a purpose, and it needs to provide the accurate information on the data as well. So how do we get to FAIR data? So first of all, and I already mentioned this at the beginning, important is standardization so that you have high data quality, clean, comparable data. This is the basis for FAIR data and data analytics. We already mentioned a few slides ago the ontology, having the same name for the same things. So you can describe density, or you can describe a specific gravity as kind of the mass of a specific substance. You also want to have the same measure of units, not that somebody is writing gram and another one is writing uppercase G, a lowercase g, gr. You know the problems. They are not comparable by an electronic measurement. Normalization is also very important, that they are all, the data that is collected is going to a common base. A good example here is that in the US, degrees are measured in Fahrenheit versus in Europe, they are measured in degrees Celsius. And you need to have one common basis if you want to compare data. And then the data needs to be stored in a very structured way so that it's easily retrievable for all the scientists on all the experiments, and it's also accessible for machine learning. Then the data is fair. When our customers today, before we come in, do their project data visualization, they need to analyze several experiments to find out the trend of a certain investigation. Again, they are extracting information from textual, handwritten documents, from instruments, compiling them into individual experiment reports that are then stored somewhere on their files. And they have many of those. Then a whole group of scientists, not only one, but many, are probably putting this into a SharePoint environment or a shared folder. So you have all the summary reports up here, and they have different formats depending on the project people are working on or on the person that is recording the information. And what is then needed is that a project manager, a lab head, a head of a research department, needs to create a chart where he can actually see the different relations of the experiments to each other. But what he is doing then is taking from the individual sources point information and is extracting them and collecting them together. A very tedious job. And this is really a very critical job, but also something that needs to be avoided if we want to benefit from digitalization. When I'm looking at the data organization, people need to document their work. They document their work in electronic lab notebooks, materials, databases, LIMS, files, and so on. And there is this data source layer where the data needs to go in. And if you are just looking at a single experiment, somebody just puts in a PDF file of his results where there is a written information about the performance of the experiment he has done. And he claims, okay, I have done my reporting obligation. He puts in unstructured data. On the other hand, if we provide him with a user interface where he has a table where he can enter all the parameters of the experiment that he measured, the data is in a structured table. But on the unstructured side, the effort for the scientist is very low. He can just paste in his PDF file and is done. Whereas on the structured side, he has to enter the data in more tedious boxes and have to go through a registration process. So here the effort of entering the information is higher. Also, if we add new capabilities, new parameters that we want to track, we need to change the tables underneath. So here the effort is higher. In the end, we want to take data out of the data source layer for visualization, personal productivity tools. You saw the report that we were generating before. And normally this is done via an integration layer. So something that reads the data out of the data source layer and prepares it for the visualization. And in case we have only stored unstructured data where the effort was low, now the extraction is much higher. We have to provide algorithms that can read the PDF file and extract the temperature from it or the reaction yield or whatever we are looking for. If we are feeding data also into the data marts, it's the same. If we are going from the unstructured data, feeding it into a structured data lake, effort is high. However, if we look then to the right side, where we have put in the data in a very structured way, then the extraction here is much lower because the data is already pre-formatted and I just need to upload it into the data lake. If we are looking at model building, it's the same thing. In the model building, and we have unstructured data, the extraction of the information, preparation of the data for building the models, it is much higher effort. Whereas if I take the data just out of the data lake, where it is already structured and normalized, then the machine learning and building is much easier. So now there is really the kind of gap between how do we best capture our information. And that leads me to what are companies considering a successful digitalization project and what did they actually consider when they do this? So first of all, it's not just only the data, as we already said before. It's the whole experimentation process. It's the easy way of collecting standardized data, finding an intermediate between the two extremes that we looked at in the previous slide. Of course, when we remember the first slide that we looked at, it needs to be all fully integrated. The workflows, the instrument, the resources, everything needs to work together to really be a successful project. It needs to be driven by the whole organization. So there is every aspect of the research organization needs to contribute to this project. And it's the research management to enforce that electronic systems are used. It's the IT department that needs to work on providing the environment for the scientists. It's the scientists adopting and promoting the systems. Very important, already we discussed, is providing data access security so that only the people that are allowed to see information can see it. And it's a scientific support for the scientists so that they can get predictions, recommendations of what experiment to do next based on the data that they have already gained in the past. This scientific support for scientists is something that is a really critical thing. And I was last week at a conference in Berlin where we discussed exactly that point. And there was this notion that scientists have the idea of protecting their knowledge and not making the knowledge available to everybody so that they are securing their status in the organization. Discussions around people who are in an analytical department for separation of new mixture of materials. A knowledgeable scientist takes maybe 5 trials until he finds the right combination of a column and the solvents to separate those products. An untrained new scientist maybe takes 20 approaches until he finds the right solution to separate those. And the fear is that based on the experience that is already in the system, when all the separations have been already collected beforehand, an artificial intelligence or machine learning algorithm could propose a solution that is already right at the first time. But in the end, I think this knowledge that is generated, it is a property of the organization. And this is also something that needs to be really looked at. What I'm recommending my customers is start always with the end in mind. What kind of questions do you want to ask your digitalized systems in 5 years? What kind of questions do you want to have answers to? Because that's then determining how do we want to structure our data, which parameters do we need to collect, and which ones can be just documented. And also, I think when an implementation comes into place, the expertise of the people implementing your solution is much more important than the solution itself. With our services department, we have implemented many customers, bringing them from paper to digital environment. And we have seen many things that were not working out, and we can provide our next customers to going down these dead ends or pitfalls, because we've seen it, we've been there before. And this is a very important asset when you are considering moving to digitalization. The environment that Biovia, Dassault Systems are providing for the lab is our lab management solution, where we can support different sciences, chemistry, formulations, analytical application testing, biology, you name it. We have, this is like a circle where you do your experiments, and normally it starts with somebody requesting work, and we need to confirm, can we actually do this request? We need to be able to look at resources. So we provide the samples, managing all the samples, the materials, chemicals you need to do your tests, managing the personnel, the equipment, registering products into a biological or chemical company database. If we are looking at analytical data, then it's mostly that you have to execute standard recipes, SOPs, methods. And we provide an environment to develop those methods, adapt them, and manage them, so that then the scientist, when he's carrying out the experiments, he can prepare the test and perform the test by scanning barcode samples, the material samples, knows about expiration dates. He gets the data directly from the equipment, knows that the equipment is in calibration, can do this also for biological assays. And then in the end, we compile the results, analyze them in a visual way, and send them back to the people reporting it. This is the way how we are supporting our customers. And we have modules for all the different areas that you see on the screen. So in the last two slides, I want to talk about the customers that we are working with. One example, this is Evonik. They presented already several times at our user conference, so I can name them publicly. There was need really to have a central electronic lab notebook for all their global sites. We are talking about 3,000 scientists, and it's different disciplines that need to be integrated into one environment. Also important is that there are different departments doing similar work. So agreements on those implementations have been very important. The idea was also to protect the IP and handling also the data in a lab setting, where this business to business NDA and non-disclosure agreements are key to separate the data. The value is that we have actually brought them a system that covers those disciplines, a central repository for all the R&D data, where the data is actually protected. We reduce time, unproductive time for the lab scientists. They are quicker to produce new materials, new products for their customers, all secure, and it's protecting the IP of their business partners and of Evonik. The second customer I want to talk about is Huntsman. Here we are looking at a phased approach. Huntsman also has global sites in India, in Europe, in the US, where we are working with, and also in China. So the goal was to have one global ELN solution. And for Huntsman, especially the formulations are a very critical aspect, since they are dealing a lot with adhesives and high performance materials. They also wanted to have the data all collected in one central place and create a digital backbone for the laboratory. Because what they want to do now is, since they have implemented the system last year, to also bring in, on the one hand, more structured data execution, and now starting also to look into artificial intelligence and machine learning. And What they are aiming for is model-based guidance of experimentation. Again, reducing the unproductive time for the lab scientists and have a single source of truth for all their information. So finally, conclusions. What I'm seeing in the market is especially this agreeing on standards within the scientific organization, ways to harmonize the processes is a difficult task. Here, help from an external partner that has seen this kind of struggle before is imperative to have a successful project. I would call digitalization not just implementing software, it's a business transformation. It's really to review the processes that are in place, challenge them, and go to a better, much more agile environment. I think material science companies in general need to define how they want to do their data analytics, and the technology that is put in place is just enabling how the company wants to do their data analytics strategy. And this, in the end, influences the way how data needs to be stored. And on the one hand, you have already seen that Dassault Systems provides solutions for lab digitalization, but we cover the whole process from ideation, requirements coming in, over competitive marketplace, competitive analysis, patent analysis, to project management, the lab execution, to scale up production, delivery to customers, and feedback from the customers. All that can be delivered in the 3D experience platform that is the basis for our solutions. And with that, I'm done with my presentation. Thank you.
Thank you, Dr. Frank Schaffer. And it was a nice presentation with the two case studies that you talked about, one with respect to Evonik, where 3,000 scientists are using it. And the second was with Huntsman, where 750 scientists are using your product. Before we start the panel discussion, there is an online poll, and this is only for the delegates. So I would request all delegates to participate in the online poll. There are 4 questions, and you have to scroll down and answer all the 4 questions, which is there in front of your screen. The first is on how do you currently store laboratory scientific data? This is a multiple choice. You can pick any one of the 4. The second is on how do you currently manage chemical inventory, EHS, SDS, and samples for R&D? This is also a multiple choice question. You just have to pick one. The third is, do you currently use any laboratory process execution software? There are 4 choices that you do have. And in the 4th, which is the last one, would you be interested in one lab deployment in your organization? So this is the final set. Now let me open the panel discussion. After the panel discussion, we will have Q&A. I see 6 Q&A. I would request all my delegates to keep typing in their questions whenever they feel like, and not wait till the end. And we will come back after the panel discussion is over and take those Q&As which are there in the Q&A window, and help you solve your queries moving ahead. So we have taken around 14 questions, and some of them would be answered by all our key speakers, and some of them would be by individual speakers. So the first question that I am posing to all my industry friends is, how do you visualize the laboratory of future with respect to your company's R&D operations? So here I request Bijal Matkar, R&I Director, Solvay Research and Innovation Center, India, to give her views. So over to Ms. Bijal Matkar.
Yeah, thank you, Praveenji. And let me kick off by saying, Dr. Frank, I really enjoyed your presentation, very precise and exactly, you got the nerve of the system is what I would say. So to answer your question, Praveenji, like if you talk of the laboratory of the future, I would say that I do not imagine. So we're talking of digitalization, but I do not imagine, robots taking over people and it's a cool system 20 years down the line. The reason I'm saying is that we still need to work on a business R&D perspective. We still need to work on solving the problems of the planet and solving the problems of the future generations, right? While making money and making our business sustainable and profitable. So I see digitization as a very important and integrated part of achieving this goal. So if we are talking about 20 or 30, 40 years down the line, we are talking about sustainability, we are talking about industry 4.0, we are talking about circularity. And this is where I want the digitization to play a part, whether it is respect to efficiency, whether it is in respect to problem solving, like at a faster, much faster pace, or whether it is related to walking hand in hand with industry 4.0 so that industry is able to achieve its goal with the help of digitization. So digitization for us is not a cool tool. It is something which is kind of walking in hand for a better future for all of us and the generations to come.
Thank you, Bijal ma'am. I come to Dr. Jayan Tomari, sir, with respect to your company's R&D operations.
Yeah. Hi. Good afternoon, everyone. So nice presentation earlier. And my colleague said rightly, yes, I think if we see 10 years back, digitalization was sort of fancy and people were considering that, yes, if you have more money, use digitalization. But I would say a lab of the future, probably digitalization is the way. And I would also see that even startups are also in this. They have realized how digitalization would play a major role even in startup. So this is going to come. There is no stopping digitalization. But like what sort of data we want to collect and how we make value out of it. Probably each firm would differ in that. For us, yes, we are at R&D, but we are also what we do. It directly goes to customer. So to create a customer delight, what product goes to our farmer and what sort of feedback we receive. For example, a formulation product, whether the formulation works fine or it solidifies. So if we that sort of feedback, if we get and digitalization is a tool where we get such a feedback is the possibility, and we have also the tools implemented. So that's how we could change some of the things very quickly rather than waiting for 2 years down the line and so on. So that's where even at R&D, we are connected indirectly with our customer. That is, final customer is the farmer, and that's how we cater to the needs. Even the need gap analysis is also coming directly from the farmer. So that's where our R&D pipeline is based on what a customer would need and what is their pain areas. So that's how we work with this digitalization to make some of the decision making. And going forward, probably Gen Z is coming already. So they would not like to spend time to go through the journal articles, and also they will be more relying on e-platform. So are we ready to welcome next generation to our lab? So that's where I think digitalization would be the key. And when we lose people, earlier we used to lose information as well and expertise. But we see that with digitalization and when newcomer joins the project, probably it's very easy to start in a project for a newcomer. So all this, I think digitalization will play a key role, along with more and more data generation. We look for data generation very early in the process. So that's where we have less failure at scale up KG lab and pilot trials. So that also, and if we integrate instrument, the data what we generate has more value. So probably what we put in data will come out during our evaluation. So capturing data is the key for us. So I would say yes, and technologies like flow chemistry and evaluation of biologicals through sort of digitalization platform would play a major role going forward.
Thank you, Dr. Jain, for your initial views. Now I would request Mr. Ganeshan Balakrishnan to give his initial views.
Hello, everyone. Thanks, Dr. Frank, for that wonderful presentation. And thanks to my colleagues who talked on, the laboratory of the future topic. As far as our industry is concerned, we do practically, everything, from the purchase to the sales, everything is practically covered under the digitization. Yes, most of them are integrated, not all of them. We are in the process of doing it. So how I would visualize the laboratory of the future is, perhaps this generation who is talking in, the panel members here, we have seen, chemical abstracts in the book form, and we are also seeing the chemical abstract in the digital form. So, I think we had the privilege of working on both ends of the, the digitization, I would say, non-digitized to the total digitalization. And I think some of us will be still coping to come to terms with that, but I think faster the better. That would be the way we should be looking at it, and integrating all the data that is possible, possibly generated by the various, various sections of the lab, like the analytical, how it is integrated to the R&D. Also now, I think the latest thing that is coming up is the artificial intelligence and machine learning, where you design the experiment before you get onto the table and start doing this stuff. So, I think that would be the future. But having said that, you cannot remove that human factor from there, because all these things work on human factor. So, a wonderful merger or a wonderful balance of the human versus the digitalization will do wonders. That's what I believe.
So nice point to start, sir. Balance of human versus technology, human versus digital. With that into background, now I open it up to different questions for our different speakers. This is for Mr. Ganeshan Balakrishnan. What is R&D innovation in the current situation in the Indian chemical industry? Is it for new molecule / materials development, process optimization, cost reduction, or sustainability? Or is it everything encompassed in one thing? So over to Mr. Ganeshan Balakrishnan for your views, sir.
So, we have a terminology for Indians, jugadus. We do a lot of jugad work. Jugad is, if you ask me, is an innovation. You cannot do jugad without, knowing the stuff in and out, but at the same time, you try to tweak around and make sure that, things are done in a totally different way. I don't think you can have jugad technology anywhere written on a piece of paper or in some books. You cannot learn that. So that's what Indians are about. And there was also a perception. That's what I would say. It was a perception that we don't innovate, we copy. But if you see holistically, I think the big scientists who are working in IBM or all those multinationals, a majority of them are Indians who bring out original ideas. It's only that, in the context of quote unquote Bharat, India, we are jugadus. So, I think going forward, I believe it has to be all encompassing. That is, You should have new molecules, the basic research, of course, the material development, which is a major part. Process optimization, I think it is ingrained into our system. So is cost reduction and sustainability. So I think going forward, it will be an encompassing kind of a future for us. Thank you.
Thank you, Ganeshan sir. Now I come to Dr. Jayant Umaria, and the question that I'm posing to him is, what factors or drivers will determine funding for lab IT operations in the Indian chemical industry? Is it data security, longevity, knowledge transfer, return on investment on innovation, efficiency, productivity, and minimizing human error? So which best suits, sir, according to you, for the lab IT operations? So over to Dr. Jayant Umaria.
Yeah, probably it's a mixture of all, I would say. It's not one one for us, because what we generate data is an asset for the organization. So we need to protect this data, and this data needs to be available to the scientists who are working on those projects, because with digitalization, probably going forward, we are currently in the transition from paper to ELN, electronic lab notebook, with integration also to the instruments and so on. So going forward, rather than searching outside databases like SciFinder and all, probably once we have database, people would search inside for any processes for similar type of transformation. And when we develop processes inside, so much data has gone behind with standardization of those sorts of experiments. So probably this would also increase the efficiency of our scientists, rather than doing 20 experiments to find the best condition. If they are already getting the best experiment to start with, so that also would increase the efficiency. And currently, due to registration regimes and talks regimes, getting new AI since last probably a decade, AI is going through innovation pipeline. They have reduced, and with digitalization and internal databases, probably I think scientists and whole research people would enhance their productivity with internal data. And with this, of course, return on investment would go up. We are seeing that happening slowly for last 5 years. But I think going forward, with help of digitalization and internal database, people has realized what is the benefit of digitalization. And once implemented, I am sure we'll be able to increase the efficiency of the R&D sector, and of course to the business.
Thank you, Dr. Jayant. Bijal, the question that I'm posing to you is, you would have seen both the paper-based laboratories, and now you are also seeing the digital-based laboratories. So what are the challenges that you faced in the conventional paper-based laboratories? Why is there a need to shift towards digital labs? Keeping in view, due to the COVID, we started doing remote working. And now with what we can say, faster time to market, then we are looking also at collaborative models across the globe, within India, outside India. So how do you see the two scenarios, and if you can do a comparison of the two?
Definitely. So let's go to the conventional ways of doing things, and I would say that there was nothing wrong with that till a couple of decades ago or a couple of years ago. I believe that Dr. Jayant and Dr. Frank have already, in a way, covered the challenges that come with conventional paper ways of doing things in terms of data finding or the lack of it, data storage, losing your know-how when an employee leaves the organization. So these are very standard things. The data is not findable, and sometimes what also happens is that as the years mount, you start to lose that data because you don't know if it is not documented properly, or the person has not handed it over properly. Especially organizations like Solvay, where we do a lot of research which is very, very in-house, which is very indigenous, it becomes difficult if you start to lose your good work over the years, uh, just because of the paper thing. So definitely there is an advantage of being the fair system, as Dr. Frank had explained to us, on findable data, data that is usable, data that is reusable. So this is very important. Just to cite an anecdote from my own life, and this is not directly related to R&D, why I believe that digitization can play a role. So 11 years back in 2011, I was working for Solvay and I was a process engineer in the field. And I took some time off to work in a hybrid model, or work from home for due to personal reasons. Solvay was very good to kind of offer me that about a decade ago. And that's where we introduced the digitization in a plant environment. So sitting at my home, I was able to see what's going on in the plant for which or the unit for which I was responsible for. We had an extremely important project going on at that time, and the project was delivered on time, and in fact, we exceeded the expectations. So what I'm trying to tell you is what you just pointed out in terms of business continuity. Some of us, we do not realize how important it is in today's world to be a globally collaborated system. So I'm sitting in India, but day in day out I'm working with my colleagues in Europe, in US, in Brazil, and having the similar structure, having the same thought process, or having the same platform to work upon is something which is very important, and digitization can play a huge role. So it is not tangible, it is not going to convert into money tomorrow morning, but the intangible benefits that come out of it. Today we are talking about smart glasses. So Solvay has already started its digitization journey. I'm particularly implementing it in the same in my R&I center since the last 2.5 years. But we have bigger plans. We have something where you have digital smart glasses. You wear that glass, and then there's somebody else who's wearing it, and this person sitting in Germany or this person sitting in the US is able to see the same thing in my lab, what I'm seeing in front of me, like 6,000 or 10,000 kilometers away. So I think we have just scratched the surface. There is much more that can be explored, and as you get accustomed to it, there are more things that there is no limit to human intellect, and there is no limit to science, uh, as I know, as Solvay says. So I definitely believe that we have just started the journey, and there is much more potential going digital from the conventional way of doing chemistries.
Thank you, Bijal. Now I come to Dr. Frank Shafar, and taking the leaf from Bijal, where she said that we have just scratched the surface.
Yes.
My question to you, sir, is how will more automation of lab help companies in the long run, and how does it benefit companies? So
Yeah.
over to Dr. Frank Shafar.
Thank you. Yeah, I think very good comments from my partners before speaking about those topics. I think regarding this question, just scratching the surface, there are many new technologies now coming on the market where we have to see which ones are applicable and bring really a benefit into the lab. We talked about smart glasses. There is also voice recognition to track the work you are doing without touching any keyboard. There are glasses that are actually helping you to see what kind of materials you have stored in a cupboard, for example, to find the right sample, indicating it, highlighting it. So those things are coming up, and they will be helping in the future. I think in the end, they will help to make the experimentation process smoother and easier. In the end, it's coming back to what I had in the presentation. The experiments are there to generate the results. This is what will not change. This is always going to be there. There might be automation that helps to do this more efficient, faster. But in the end, the result of the experiment is what is important. The more experiments you do, the better experiments you do will determine if you are successful in this kind of area. I think it needs to go together, this automation and the collection of the data. Because in the end, you want the scientists to focus on the right experiments, to confirm what the models have told you before, so that the decision on advancing a material, an experiment to the next stage can be made much faster. I think only companies that will be able to react faster to market needs will be the successful companies in the future. We see this tremendously in the consumer packaged goods, where the tastes of the consumers are changing very quickly, within weeks, within months sometimes. And the chemical industry, I think, is seeing now the same requests, because car manufacturers, home style manufacturers, they are demanding new properties, new materials in a much faster way. And only those companies that are able to respond to these market needs will be successful in the future. And it will only work with digitalization.
Thank you, Dr. Frank. Now I come to Bijal and Dr. Frank once again. And here the question to them is, Industry 4.0 is moving far ahead, whereas Lab 4.0 is lacking, is lagging. So, and it should be the other way around, because if you are looking at R&D, if you are looking at innovations, if you are looking at new material, it should be the other way around. Lab 4.0 should lead Industry 4.0.
Yeah.
With that into background, since you are industry leaders, wanted to know your views, how this can be improved upon.
Yeah.
So over to Bijal Matkar and then to Dr. Frank Shafar.
Yeah, that's an interesting question and very, very correct observation. I think, and this is my personal experience in the last couple of years, is it is twofold. The first one is probably related to the sheer volume effect, as I call it. So, if you look at the whole industry, only 3 to 4%, if you're lucky, of your money goes into R&D, because R&D still is considered to be sort of an investment as compared in a capitalized world. If you're talking about capitalization, R&D is still considered to be an investment or something it's nice to have kind of a thing. And this is a general statement. I'm not talking about any particular sector in general, in particular. So as a result of it, the people who are designing the digitization, the probes or the material which is associated with it, or the amount of work that goes into designing such things, obviously there is not too much of focus on that. The second thing which I believe that industrial automation finds a place in itself is because of incentives of HSE. So you automate because you don't want your people to move or walk 20 kilometers just to close a valve, or 5 kilometers just to take a reading on pressure or temperature. I don't want to blow up a PSV, and that is the reason I'm going to put an interlock somewhere. And for that interlocking, I would need something which is automated, right? So these are the incentives that we have in our industrialization, which at the moment do not exist at the R&D level, because R&D level is still bench scale. We are talking about 50 grams, 100 grams, maximum a kg of material. This is very easily doable by one human. This human is trained in synthesis. This human is trained in running his columns and GPCs and UTMs and whatever machines we are talking about. So why do I need to, without the incentivization of a capitalist return, why am I going to do this? And as a result of it, if you integrate on a back-end side, when I was studying engineering, though I was in chemical segment, I was taught instrumentation and process control. I don't think that even on a curriculum basis, our scientists are taught the importance of digitalization or digital tools, or how probes can help you, and how data can help you to be a better or more effective scientist. So I think it's the whole chain that we are talking about. And the second thing is related to more of, I think, mental state, because the moment you talk of R&D, you talk of IP, you talk of human intellect. And as it was mentioned before, obviously, we are protective about, because this is direct human intellect translating onto paper, and the sheer fear of sharing it with the rest of the world, it is it's a barrier that all of us would have in the professional as well as in the academic world. And that is the reason we tend to shy away from because of the IP segment aspects of the R&I. So these are the two factors I think uh, that could be playing a role in lagging of Lab 4.0 versus Industry 4.0.
Dr. Frank, your views?
Yeah, I can just confirm what we just heard. I think this is really an issue. I think also when we are talking,
Which is not good for you, sir.
say again.
Which is not good for you.
No. I think this is okay. But what I'm seeing is when we are talking about Industry 4.0, we are looking at industry processes which are run through day by day during the night, all the same process every time. You're collecting all the information. You have everything automated. It's repeated work that is automated, and I think there it has its justification. When we are looking at R&D work, I think there is more diversity. People are considering new things. They are trying out new things where it's not sometimes even possible to automate the processes because you're doing something completely brand new. However, there are routines in the lab that are also done on a regular basis. When we are just looking at analytical labs, where you have standard tests that you're running every day, day in, day out, and you need to collect the information from those. There, I think automation is there, and like an automation 4.0 is what people are looking at. I'm working also with people in the pharma industry, and I'm looking at virological labs that are passing, for example, the corona tests, and they are also now in this state of automating their environment. Things that the users, the scientists are doing now step by step, plate preparation, incubation, testing, collecting the results. They need to get to a much higher volume. And the only way to do is to bring in automation by robots handling all the steps in between, so that the ideal goal is to come in the morning, put in all the samples that need to be tested. The robot runs in the back end, the whole automation is orchestrated, and at the end of the day, the results are coming back, and you just look at what has been done. And I think this is something that we see in the standardized area more. I think also important is to look at the way how data is exchanged with instruments during automation. And there, again, standardization is a critical part. There are initiatives like the allotrope or the animal standard that help to get data from the instrument in a concise and comparable way into an environment where the scientists can then use the data and work with the data. And that's going to be helping a lot to get the 4.0 status into the labs as well.
Sir, I'm coming to the seventh question, and this is addressed to you. The researchers and scientists are they are also working on these things like data curation, data extraction, and data cleaning, in addition to the core experimental work.
Yeah.
So how can they overcome this challenge so that they can focus on the core area? And
Yes.
is it important, or is it that they have to do both at the same time?
What I'm seeing in the industry, that companies are starting to bring in data scientists, data analysts, that their task is to take the existing data and help to build models, do data analytics, find trends in the data that help the scientists to advance their work. And the data analysts who are supposed to build models and feed the models with new data are spending 80% of their time cleaning the information. Remember in my discussion about structured and unstructured data and high quality fair data, this is not what the companies have today. And I think it is there in certain areas, but I think the majority, especially of the legacy data, is not in this kind of format. And I think only through data acquisition in a very structured way, this work of the people analyzing the data will get easier, and real benefits can be taken from building these models and using those models. And this is a corporate decision that needs to be done to enforce that data is collected in a proper way so that the scientists, the data scientists, can extract this information. We need to give the scientists simple ways to enter the information in the right way so that this building really gets easy. And we need to leave enough flexibility to document all their work, because what you also don't want is systems that are in place that can handle all the different data points, but nobody's using them because they are too complex. And that's what you want to avoid. You want to have high user adoption, because otherwise all the software systems are just useless.
Thank you, Dr. Frank. The 8th question to Google Marker. How will the digital lab documentation process help in data storage, patent filing, and dissemination of information/knowledge? So over to Ms. Bichel Marker.
So this is a very core topic that we are talking about on, we touch base on ELN, or electronic lab notebook instead of the normal paper, or LIMS as we call it in the analytical section. So looking into the sample. So these are very basic things, and this is something which we know as a standardization, right? So the way the data is captured at Indian site will almost be the same way as that is captured at say somewhere in Europe or somewhere in the USA. As a result of it, what happens is when you're reading it, when you are looking into the effectiveness of this, and most of these topics or most of the projects are international projects, I think it gives you a same platform, a similar platform, without having to waste too much of time in just making some I would say some good sense out of it. So there is definitely an efficiency point and data storage point for the organization. That's an advantage that we're talking about. As far as patent is concerned, I think it is, I may be incorrect, but it may not accelerate patent processing on the other side. I mean, you need to do your due diligence, what you need to do. But at least in for the patent lawyers, or the ones who are actually helping you file the patent, having all the knowledge or having all the data together in one go is definitely going to bring down their pain of referencing, so that there's, at least on the organization side, that the patent filing is accelerated a little bit. The dissemination is the where that's my favorite topic out of this, because the way you disseminate the data is how you use it and how you put to the best use. I'll just give an example. Recently in Solvay, we put together for a business unit data worth 40 years. So all of the 40 years data was brought together, and it is cited as one of the successful digitization projects of Solvay. So just imagine the amount of work that is goes in, that is integrated now, and that is available at your fingertips. And it is still not going to uh, surpass the human intellect. After having that data in front of you, you should also know how to use it. So your professionalism or your intellect is still at play, but you are actually taking the common intellect of the people before you, who have put in a lot of hard work to make your I would say to make your organization successful. And I really want to cite Dr. Jayant here, where he talked about customers. So being able to go to the customer with this kind of a data, or the effect that has come from this kind of a data, the result that comes from this kind of a data, you can actually win the customers, you can win their trust, and you can do better for your business for sure. So yeah, I again say that it is digitization at the very basic scale in the labs.
Thank you, Bijal ma'am. I would request all my delegates to please type in their questions. I still have, I will extend the timing by another 15 minutes, because I have completed 8 questions, 6 to go, and I see 12 in the Q&A window. The next question is to Dr. Frank Safar. Data is coming from different sources, be it lab data, consumer data, and the quality and manner in which these data are presented. how do you manage this data and so that it is accessible on demand for analysis? Because it's not easy to, what we can say, capture these and keep, and then retrieve data whenever it is being required and use it when the scientist needs it. So my question to you, sir, how do you manage all these?
I think it's important when you collect the data that you have from different sources, when you're collecting the data from different sources, that you have a common backbone. This is really imperative, that there is not data stored in different places and then replicated, but that you have one system where all the information is stored. I think we are seeing this with many of our companies, that a lot of effort is lost in integrating different data sources, providing APIs, providing connection between the different data sources, data places. I think it's only then when you store the data in this clear single version of a truth, and that it's also well documented what your data actually means. Only then you can really take advantage of the data that really needs to have this connection. And I think this common backbone is really a key thing I'm seeing.
Thank you, sir. My question to Dr. Jayant Umaria, to him is, how can big data or artificial intelligence, AI, and imaging help in speeding up the innovation process? Over to Dr. Jayant Umari.
Yeah, so I think we have, as we speak, probably we have now almost so many huge TB of data lying with probably each of us. But how to make use of that data to predict what are the projects we need to take at R&D? I would say one example during Corona time is like milk and Amul. Amul has digitalized all its platform, including truck and how much inventory they have, what products they have. And also they know what is the trend of Indians, what sort of product they will consume. So when nobody was taking milk, Amul took the milk because they had already the confidence that they had data that consumer will start spending, consumer prefers this product. And that's where they have transformed milk into value addition product. And that is the power of digitalization. And so here also we see that we are doing probably thousands of experiments before launching new formulations. And at a time now, currently we have data across line with various scientists, and then to collect that data and decision making, almost there is a lag of now 3 to 4 months. And probably with this big data, and as it is, we are doing routinely imaging, and this would speed up. And if we have our dashboard created, probably we know which is the best formulation, what soil our product works on a go. As soon as we put the data, probably it will flash at the dashboard which we created, depending on the KPI of the project. I would say this would certainly help us to reduce the time gap almost by 30 to 40%. In mainly during bioefficacy analysis and so on. And this is not only at our field, but even in pharma, analysis has been done. They have all the imaging has been done, but to enter that into empirical format data and then to get analysis, that if that changes and directly we can automate this process, this would certainly help us to get quick data and it would speed up innovation. That's the power. Yeah.
Thank you, sir. My question to Mr. Ganeshan Balakrishnan would be, what component or software would you like to include in the laboratory of future, and so that it fulfills all your requirements?
I think all of us have talked about this. See, in our kind of industry, which is the pigment industry, the last known pigment that has gone commercial in a big way was some 30, 40 years back, which is diketopyrrolopyrrole. After that, there has not been, any major success for any of the new pigments. So artificial intelligence may be able to help, decipher some of those mysteries, in this field, in the sense that today, all of us know that, the basic pigment industry or the dye industry is hugely polluting. Even though, the innovations have been done to take care of the mother nature, but there is a limitation. This all of us understand. I mean, my thought process would be, if artificial intelligence can be applied to come up with molecules, come up with the routes of synthesis, which can actually, benefit the mother nature. And this is not only for dyes and pigments I'm talking about, in general, where chemical industry is looked upon as a highly polluting kind of, industry in general. So my thought process is, yes, artificial intelligence or, the machine learnings, if they can be converged into getting, newer solutions and better solutions to the existing problems.
Thank you, sir. Dr. Frank, you talked about two companies, which is Huntsman and Evonik.
Yes.
Are there any national case studies with respect to lab digitalization, showing how companies have benefited from this software of yours or the complete solutions that you are offering?
Yeah, I think there are numerous companies that have gone this step of digitalization, and many of them have presented at our conferences their journey with us. One interesting use case, maybe not in the chemical but in the CPG industry, is Unilever, who have also implemented our components to collect information, and they have gone already like to the next step. They are not only collecting the data, but they also have built models that help the scientist to go into the right way. In the past, when a Unilever scientist got from marketing the objective, our mayonnaise needs to be more sour in the next year because that's the market trend, then classically the scientists have started to formulate 100, 200 new formulations of mayonnaise and measured their sourness and took the one that was giving them the best results. What they are doing now is they are running a model. They are running a model which has been built with the data that has been collected over the past years and which will be fed with virtual formulations. And one of the models is predicting the sourness, and one of the models is predicting the viscosity, and one of the models is predicting the color of the mayonnaise. And then they can find these formulations. They are feeding it with hundreds of thousands of potential formulations. And then they are selecting the ones that give them the most sourness with the same viscosity and the same color. And then they are doing maybe 10 experiments instead of 100, which is completely speeding up the process so that they can meet the targets from marketing. And I think this is the goal that all of our customers have these days, to really employ these models that are built and giving them back to the scientists who are generating the data, to focus them on the successful experiments.
Thank you, Dr. Frank. We have two more questions to go, and then I will open it up for Q&A. One question to Dr. Jayant and the last question to Dr. Frank. The question to Dr. Jayant is, how important is it for organizations to adopt the green first, right first approach to process scale up and product lines into sustainable ones? So over to Dr. Jayant Kumar here.
Yeah, green, I think at Godrej, it goes like we have a separate department for Go Green, where we have even KPIs defined to reduce, reuse, or recycle, for example, water, and also go for green energy like solar energy. So with defined KPIs every year for every business. And with digitalization, yes, we are going green by not using paper. It's all on electronic. And during COVID time, I think for legalization, we used to sign for all our financial statements and all by taking huge amount of printout. But I think this COVID told us how we can go also on online sort of approvals. So that was also big learning. About for R&D process, yes, I think we are going away from EC formulation. Even where we have EC formulation, we are using again green solvents, which are coming from fermentation-based solvents, and avoid petroleum sort of EC formulations wherever possible. Even for the existing process, if we have opportunity to reduce the waste, yes, we are taking up that process and then we also implement it in the production. But it takes time, so that whatever we do also had probably sometime more lead time. So the project, if it is valuable, then only we are able to take and modify those surfactants for older projects. But new project going forward, yes, green is the only way to sustain the business and also the planet. Yes.
Thank you, Dr. Jayant. Taking the leave from Go Green, my question to you, sir, which is the last question, and then we will open it up for Q&A. I request all my delegates to please type in their questions so that we can take it up. I have extended it by another 15 minutes. So we will wind it up exactly at 4:45. So my question to you, sir, is with sustainable innovation, companies focusing on sustainable innovation, and with those data not being available in the present format, because these are not being captured by the industry, not being captured by the company. So how, as a solution provider, how can Dassault Systems help the industry in this regard? So your turn, sir, Dr. Frank.
Yeah. So I think on the one hand, we are providing, as I already described, a comprehensive solution to handle all the physical data that is generated in the lab. So everything from inventory management, method development, method execution, data collection, instrument integration. Classically, we can handle all this in our lab environment. I think a big differentiator to our competition is that we are looking at this information also from a scientific way. We can enhance it by, as I already described, data models based on the data that is collected, provide models that can predict the outcome of future experiments, and also the atomistic modeling, where we have capabilities to predict materials and their properties on an atomistic level, and as well as confirmations of the different substances that are created, looking at reactions. Why are reactions working? Why are they not working? I think this is the one hand, that we are adding the scientific component to the data acquisition. But then, as I said, BioVia is part of Dassault Systems, which can cover this complete process from the ideation, when a new request is coming, from marketing, from the consumer, over idea generation, brainstorming, social interaction in a team, from there breaking out into a project, defining what the project steps are, doing the research for it, delivering the results from this research, and then handing over the information seamlessly to scale up and production, so that then the new goods can be produced, and then also the shipping and feedback collection from the customers. I think this whole product development cycle can be covered by Dassault Systems. And you were asking about when the data is coming from so many sources. We are providing this one environment where everything can be collected and stored with the scientific capabilities to analyze and understand why things are working and why they are not working. So this all in one platform on structured data, I think, is really the key that we are providing.
Thank you, Dr. Frank. We have come to the end of the panel discussion. I will take up, there are 14 questions that I see. And I would request all my speakers to give short answers so that I can take as many as possible. And we have still 16 minutes to go. The first question from Rahul Deshmukh, and the question is, sir, in membrane system, how machine learning can apply? So, Dr. Frank, would you take this up?
Sure, sure. We have done prototypes for our customer where they are looking at membranes for gas separation, and they have done a multitude of experiments and collected parameters of the membranes and also parameters of the performance of gas separation, and have taken this data and kind of did a visual data analytics approach to show what the relationship between certain membranes and the gas permeation is, so that you can use the tool now to, if you are having a given gas mixture, to pick a potential membrane that is actually able to do this kind of separation.
Vinay Desai is talking about, does existing LIMS of QC lab make lab digitalization easy? Vijay, would you like to take this? So you were talking about LIMS.
Yes, so LIMS is nothing but what you call like a software which is helpful in capturing the digitization, out capturing the data that comes out of any analytical equipment directly in a soft format. So instead of taking readings manually and noting it down, LIMS is a system where you will get the readings, you will get your analysis of your HPLC or GPC or whichever instrument you're running, all at one place. It's a easy once you learn it, like like any other apps that we run on our smartphone. It is run in the similar way. The IP can be very well protected because you can choose who can see the results and who does not have the authority for that. And once you learn the system, you need an initial training like any other software. It's pretty easy to use. So we are still in a nascent stage at Solvay, but this can be this can be used for digitization.
Thank you, ma'am. Sanjay Soni is talking about it's a what we can say, the question is not complete. Let me complete the question. He says we have implemented SAP. So what he's saying that if we have implemented SAP, how is your product or how will it get integrated with the Dassault systems is what I believe the question is from Sanjay Soni.
Yeah. I think SAP is present in all of our customer environments, either SAP or a different ERP system. And especially for the production, this is where it's paramount. We see more like the product definition and the product life cycle, what we are covering as Dassault systems, and we are seeing each other like in parallel. You can probably see the Dassault Systems solutions as kind of the SAP for research until the product is defined. And then we always interface with SAP to hand on the final formulation, its processing instructions, so that it can be scaled up.
Thank you, sir. This question I am putting to Dr. Jayant Diumari. And what else software or what software good for digitalization from a lab perspective?
In the sense, what are the available platforms?
Yes, that's what he is asking.
Yeah, there is this, like depends on what sort of automation we need to have. Local, we also have now, Deepak have their softwares for ELN, and also up to total project management tool is there. Then there is this IDBS is there, BioVia is of course there. So there are plenty of tools available depending on what we need to do. And of course, Perkin, which also is there. So depending on what sort of expenditure we have or we want to automate, there are various levels of solution, including integration of instruments within your ELN so that data is captured against the intermediate and final compound. So at various levels now solutions are available.
Thank you, sir. Vinay Desai question is about Is lab digitalization applicable to R&D, pilot plants, manufacturing plants, and integrated with analytical labs? So, Ganeshan sir, would you take this up?
The answer is yes. Okay. Everything can be integrated and you can take out meaningful data out of everything. Actually we have been trying to do that by way of, when you're going into, let me put it this way. Okay. When I'm going into the pilot plant, I also need to have kind of, the mixing parameters and other things come into play which we generally don't have a focus on when we are doing the lab small experiments. So all these things can be integrated and the meaningful data can be taken out, which will be useful when you are going for the scale up. And I hope I have answered that question.
Thank you, sir. Manish Prasad is talking about how is lab digitization related to manufacturing plant digitization. I would request Dr. Frank to answer this.
Yeah, I think this is similar to the answer that we already heard just before.
That we already discussed during the panel discussion.
No, just what Mr. Balakrishan was saying. I think it's important that manufacturing plant digitalization and lab digitalization go hand in hand, because things you are learning in the lab can be relevant for the manufacturing plant. In the manufacturing plant, you are encountering maybe problems and you have to feed back again and look at results from the lab. So this kind of interaction is really critical.
Thank you, sir. There is a question on, we have SAP implemented in throughout whole plant, including formulations, specs, testing results, production data. There need more software. I think we have already answered this. The other question is from Amol Kusalkar, and he's talking about how design experiment in LIMS. So who will take this up? How design experiment in LIMS?
Maybe I can talk to that as well. I think we heard already from Madame Bataka that there is LIMS, which is connecting instruments and collecting data on samples. I think this is the major objective of a laboratory information management system, LIMS system is. When you are looking at designing experiments, then you have a certain purpose in mind, and you are designing certain amounts of things that you are mixing together, or certain conditions that you want to try out. And then you are doing the experiment, and the results need to be determined. The qualification of the products needs to be determined in the LIMS system. So the LIMS system is feeding data for the experiment that you are designing elsewhere. And classically, these are electronic lab notebooks, where you have design of experiments with the experimenter, with the parameters. You have design expert or other tools that allow you to really assess the chemical space, and the execution is done of the tests in the LIMS system.
One more question to you, sir, Dr. Frank, is this helpful for MSMEs, and how much investment is needed to implement this?
Sure, I think this is all important or applicable to any size of companies. Investments, depending on how far you want to take it, also the size of the company, the size of the departments. I think a very important step is also that digitalization you should not approach as like one big bang approach, but like a phased approach. And there you can start already with digitalization of your lab experiment documentation, like an electronic lab notebook, which can be really a very cheap entry point at the beginning. And then later on, you start to add on method definition, inventory management, and all those other components. So I think a stepwise approach is, especially for smaller organizations, the best way forward.
Mr. Keshav Kumar is talking about, so far talk was centered on data collection so that these could be analyzed to derive an inference. I am working in a refinery. Here I find scope in time optimization, right from sample collection to its receipt at lab to analysis to reporting the results. Early reporting of the analysis will help in better process optimization. So the question is how digitization/digitalization could help in minimization of the time at each stage. Dr. Frank, would you take this?
Sure. So I think there is on the one hand the sample preparation that is under control in his work at the refinery, but then I think the analytical lab needs to get information about which tasks need to be executed on this sample, what kind of tests need to be run, and here a proper task management system with methods defined at the back end that can be run on the samples, like an HPLC test, like a GC test, and so on, with connected instruments, is the key to really speed this up, because then the samples are handed over to the analytical department. The people know immediately what needs to be done. Automation in place if there is large volume, so that things can be automated on a regular basis. And then very important again is that the analytical department is not storing the data in their own system, and then somebody has to move the data back, but that it's stored in a central place where the requester has immediately access once the analysis is completed. I think these are the things that can help in a digitalization process to speed up this testing in the refinery.
Mr. Vivek Khade is talking about looking at the cost and data security. Many small chemical industries and startups are not liking digitalization. What will be the way forward to bring all the industries in digitalization? Let me give you a very frank opinion. Digitalization and digitization is the way forward.
Yeah.
So whether you are big, whether you are small, or whether you are MSME, you have to invest in digitalization. Chemical industries, refineries have already taken a big role in implementing it. Chemical industries are slow, but they are catching up and they will have to focus on it. And it is all across all departments of chemical industries which need to take this in a big way. So if you say that you are big, you are small, you are medium, we will not be able to focus on that. That is not the case. You will have to do it in a structured way. And as Dr. Frank talked about, that you have to keep a goal in mind. And according to the goal, you try to do different steps and move forward at the same time. Keshav Pradhan is talking about data collection was important and people started to gather lots of data using various digital means. However, most of the time during digital media was neglected and decisions are taken based on conventional methods. How effectively it can be used in decision-making process? Sir, I think the scientists out here, if they can answer, Mr. Ganeshan, if you can explain this briefly, and then we can then we will take the last question, sir.
Thank you. I think the question is how we can, do it much faster. Is that the question? Sorry.
The question says data collection was important. Then it says, however, most of the time during decision-making process, data was neglected and decisions were taken based on conventional methods. Now he's saying how effectively it can be used in decision-making process. So the data that you have captured, how are you going to use it for the decision-making? I think it was beautifully explained by Dr. Frank when he said Unilever is now looking at mayonnaise. And with respect to mayonnaise, he said he's looking at the sourness, the viscosity, the color. And since the data is already there with respect to the user preferences, the scientist at Unilever is now coming up with multiple flavors, and you know that people will like it. So that product will be an instant hit. So he's talking about that.
Yeah. So, I think having a data and not using it, I mean, it's something, which needs to be thought about once again. And you can also, look into the old data and come to some decisions which might be totally different than what you have taken. So I think.
So I think, and there were a lot of questions with respect to sharing of the PPT, depending upon if Dr. Frank, and you can definitely have a look at it. and he has given a thumbs up to us. So that will be done. Let me thank all my speakers for educating us on lab digitalization, delivering efficiency and sustainability. Once again, a big thanks to Ms. Bijal Markar, RNI Director, Solvay Research and Innovation Center, India. Whenever I call her, she's there to educate all our delegates. And she's very kind enough to be what we can say, to participate as a speaker on ICN platform. Dr. Frank Shafar, interacting with him for the first time, but very nice presentation, sir. And it was the comments and also has given you a lot of good feedback. He's the industry process consultant of Salt Systems. Dr. Jayandev Umarye, AVP R&D, Godrej Agrovet Limited. Thank you, sir, for being part of this first panel discussion with ICN. And Mr. Ganeshan Balakrishnan, who has also been a great supporter for us, who is kind enough, though there was a big delegation which was there. Despite that, he agreed to participate in this panel discussion. Thank you, sir. He is the GM R&D and Special Projects, Sudarshan Chemical Industries Limited. Let me also thank our presenting partner, the Salt Systems. Without their support, we would not have been able to educate you on this topic of lab digitalization, delivering efficiency and sustainability. Let me thank all the delegates who have registered and attended for today's e-conference. Those who have not been able to attend but have already registered can look at the recorded version on indianchemicalnews.com website.